We have one more session in here this morning, and it's going to be about microservices, communication, integration. Please welcome Kate Stanley.
Thanks. Hello. So good, I can hear the microphones working, so that's a good start. So as we just said, I'm going to talk about microservice communication and integration. My name's Kate, and you can tweet me if you want to on Twitter, but my slides aren't showing it. There we go. So you can tweet me at KateStanley91 if you want to during, but I won't respond, but after the presentation. So first, some introductions. I'm a software engineer. I work at IBM at the moment, particularly on WebSphere Liberty, which is a Java application server. If you haven't heard of it, you should check it out. It's pretty cool. But for the last couple of years, I've actually been focused on microservices, and particularly building something called Game On, which is a text-based adventure game. I'll talk a little bit more about that later, so if that's something that interests you, hold on until later in the presentation. This is actually my second time talking at Jfokus. It's my second time to Stockholm as well. I'm so excited to be able to come back and talk to you all today. Here's a picture of me presenting last year. I talked about microservices again, but it was testing last year. So if you're interested in that, then do feel free to check out the Jfokus website from the videos last year. It'll be up there. And there's my Twitter again. So what am I going to talk about today? First, I'm going to give a little introduction to what microservices are, just so that hopefully we're all on the same page. Then I'm going to talk about why communication, I think, is important, both in life, but specifically in microservices. And then what are your options when it comes to microservices, how to be a good producer and consumer of APIs, and then a little conclusion at the end. I'm aware I'm the talk just before lunch, so I'll try not to go on too much and keep you from your lunch. So first, what are microservices? Can I just get a quick show of hands? Who here thinks they know what a microservice is already and they're kind of happy with the concept? Cool, I think that's a fair few people. So I'm not going to go into too much depth. There's plenty of stuff you can go and read about to kind of learn more about microservices, but I'll just do a little introduction. So microservices are used to compose complex applications using small, in quotes, because that's a controversial subject, independent, replaceable processes, and they usually communicate via language-agnostic APIs. They give you a lot of advantages. By putting everything in separate pieces, you can scale them more efficiently, you can perhaps iterate more quickly, but they do come with some sort of difficulties as well. I talked a lot last year about how testing is something you have to maybe think a little bit more carefully about when you move to microservices. You might have to rethink your DevOps strategy and, of course, communication. So before I kind of go on into communication of microservices, I just wanted to throw it out there that microservices is not the answer to all the problems in your life. You should really consider before you go down this track, because there are advantages, but there are disadvantages too. So with that in place, let's assume that you've read up and you think microservices are the way to go, and now you want to know about communication. So why is communication important? Before I talk about microservices specifically, I'm going to talk about my team and how we communicate. So we were formed, I think it was about 1.5 years, 2 years ago now, and it was formed to look at how can we make Liberty awesome for microservices. It is awesome for microservices, by the way, but how can we make sure it's really good? And also, how can we help people learn about microservices? Because a lot of people don't really know where to turn, or they've done something very simple, but what do they do next? And we formed this team, and we thought, this is great, you know, we're going to be an awesome team and create all this cool stuff. But we ran into some issues around communication, and these were down to 3 main things. The first one is that we're in different locations. So I'm based in the UK, if you hadn't already guessed by the way I speak, and my colleagues are actually on the other side of the world to me. And that means that we also are in different time zones. So to just give you an idea, we have a meeting every day at 3 o'clock in the afternoon, my time, but that's 10 o'clock in the morning for some of my colleagues. So we do overlap on our days, but we don't completely overlap. And the final one is different languages. I'm going to tell you where all of the people in my team are from, and that might mean the languages is a bit interesting. So, as I said, I'm from the UK, there's some other people from the UK. We have some people in America and some people in Canada. The people in Canada, they don't speak French, they do speak English. But the reason I say that we are all speaking different languages is because of this quote. The United States and Great Britain are two countries separated by a common language. This has been attributed to various people, but it basically means that when I say something in English to my colleagues, then the people across the pond in the US might interpret that in quite a different way to what I intended. And then there's a different interpretation again in Canada. So although when you look at it on paper, we all think, we're all speaking English, this should work fine, there's maybe some issues there. And we've had to do some things to overcome those. And the reason I'm telling you this story is because I think this works well when you think about microservices. It's tempting to say, oh, well, I'll stand up all my microservices and we'll all just communicate via language-agnostic APIs, and because they're language-agnostic, it'll all be fine. But there are some things that might trip you up that you weren't expecting along the way. So that's what this presentation is about, kind of trying to show you where you need to take a bit of care with communication. So how did we solve our problems? Well, first we chose what data type we were going to use to communicate. So that could be text, or speech, or body language. It's kind of the main ones that humans use to communicate. We also had to choose infrastructure options. Do we use email? Do we use Slack? Or maybe Skype? And then what characteristics do we have for our communication? So that could be things like delayed communication. If I send an email, I don't expect an immediate response. I might get a response in the next hour. It might be the next day, the next week, maybe. But for Skype, it's immediate. If I phone somebody up on Skype and ask them a question, I expect them to answer me straight away. And actually, we've used a combination of all these things to get really good communication within our team and then hopefully build really good microservices as a result. So how do these things convert to microservices? Well, first, you have to decide what data type you're going to pass around. You could muck around with having some people pass around JSON or something different, but if you all agree on a data type, it's just going to make your life easier down the line. I would generally recommend JSON if you're starting out. It's the one that's kind of become the most popular at the moment. You could use XML. That's kind of going out of fashion a bit. I've put binary up here as well. There are binary protocols like Thrift available. But if you're starting off, I would generally recommend going with JSON. And then down the line, once you understand the kind of the communication between your microservices, then you can consider whether or not binary protocols is the way to go. Then you need to think about infrastructure. Do you need a service registry? Do you need a service proxy? And these are all things I'm going to kind of go into in a little bit more detail. And then there's the characteristics, and I'm going to talk about asynchronous and synchronous protocols specifically. So let's get into it. What are your communication infrastructure options? So the first thing you need to consider with microservices is you should absolutely never have known endpoints. Because one of the reasons you've hopefully moved to microservices is so that you can be more resilient, and if one service goes down, you can handle that gracefully. But if you're using hard-coded endpoints, then if something's not at that hard-coded endpoint anymore, you're in trouble. So you need a way for services to find the other services in the room. And that's where a service registry comes in. It's a store of available microservices. Depending on which one you use, it could be that it's a persistent store and put into a database somewhere or something, or it might just be a cached list of microservices available. And whichever one you choose, you should aim for it to have the following kind of 4 functions. And those are that it provides registration. So you need to be able to, as a microservice, go and say, I'm alive, and here's my endpoint. A health checking mechanism, so a way either for a microservice to say, I'm still alive, I'm still here, you can still send traffic to me, or a way for perhaps the platform you're using to tell the service registry when it thinks an application is available. Service discovery, so here there's a difference between service registry and service discovery. A registry is your list of where everything is, but you need service discovery, so you need a microservice to be able to discover what's in the registry. And then deregistration. And deregistration could be done by, say, the platform. Like if you're on a cloud platform, that might do the deregistration, but generally there will be sort of something like a heartbeat going from a microservice to the service registry, and if it misses a heartbeat, then it will automatically get deregistered, and that's, I think, the most common approach. there are many choices, and when you're choosing which service registry you would like to use, one of the main considerations is, do you want consistency or availability? There's something called the CAP theorem, which is a theorem for distributed systems, which is that you can only have 2 out of the 3 of consistency, availability, and partition tolerance. And you kind of always want partition tolerance, so you have to choose between consistency and availability. And the choice really depends on what your microservice is doing. Quite famously, Netflix kind of say that they choose availability. So for example, if I've gone and watched something online on Netflix, and then I go back and it comes up with the things that I was previously watching, rather than saying, oh, well, we can't find the up-to-date version of what you recently watched, we'll just show you nothing, Netflix choose to show the last good copy of that data. So it might be that the thing I watched yesterday isn't up there, but the thing I watched 2 days ago is, and that's enough for them. So it really depends on what your microservice needs. And you'll see kind of a theme throughout this presentation that communication, it's very important for you to understand what are the requirements of your microservice, and then that should help you make your communication choices. I've put some examples of some service registries up there. Things like Eureka, Console, Amalgamate is maybe one that people haven't heard of. That's kind of container-based, and I'll talk a little bit more about that one later. So now that you've got a service registry, everyone's registered, and you've got this nice list of where everyone lives, you need to decide how, as a microservice, you're going to call another microservice. And the first option is using a service proxy. So in this case, it's basically, I, as a microservice, will call out to a service proxy, which will then forward my request to whichever microservice I need to send the request to. And this picture here, I haven't included load balancing. And that's something that normally would be done by the service proxy. And the other thing I haven't included in this picture is caching. So I could have the microservice make a request to the service proxy. Then at that point, the service proxy makes a request to the service registry, gets a list of the services, comes back, does some sort of figuring out which one it should send me to, and then forwards the request. But that's quite a lot of kind of steps just to make one request. So if you're going to choose this model, I would generally recommend to have your service proxy have a cache of the service registry. If for some reason it doesn't have an up-to-date cache or the cache has gone away, then you can still make the request. But for efficiency, you should have the cache there and also think about how you're going to do load balancing. And the advantage of doing this is you have quite simple requests. Within your microservice, when you write the code, you're just making a request to some endpoint that you happen to know about. And then it's quite simple to test it. And you can just mock out the service proxy and you're all good. The disadvantage of this is there's quite a few network hops going on. So you're making a request out to the service proxy, which is then forwarding the request on to someone else, who then responds, and then the response comes back again. So there's a lot of network hops going on, and if you have issues along the line, then you might cause latency to your users. So the other approach is to use client-side routing. And for client-side routing, basically one microservice will have some mechanism to find out where all of the other microservices are hosted, what endpoint they have, and then you make the request direct to the microservice. And again, you need to think about where am I going to do my load balancing and where am I going to go do my caching. So you would expect you as a microservice to have some way to check with the service registry and keep a local cache of all of the services in that registry, so you don't have to go ask the service registry, come back, and then make the request to the microservice. And for client-side routing, there are kind of 2 ways to do it. You can use a client library, or you can use a sidecar. So for those of you that might have looked at Eureka before, they provide client libraries for you to make requests. They also provide you libraries like Netflix Ribbon, which do things like load balancing. And basically, in this scenario, you have nice code that you can write, you can look at it, you can understand if something goes wrong and debug it, but it is language specific because you've written it into the logic of your application. And you're going to have to think carefully about how do I make sure that where I'm using my client library and making requests, how do I keep that separate from my business logic inside my app? The second option is the sidecar model. This is language agnostic, and this is what Amalgamate does that I mentioned earlier. So the idea here is you have a sidecar that's running, say, inside the same container as your application, Or if you're using something like Kubernetes, then you can actually have one container that has your application in your pod, and then have a second container in the pod which has the sidecar in it. And this is nice because it's language agnostic. If all of the microservices in my system are written in different languages, then I can just use one sidecar and I can reuse that everywhere, and it just works. The difficulty is if something goes wrong with your sidecar, it might be more difficult to debug the failures because you haven't written the code that's making the request, so it might be a bit more difficult to step through. So those are kind of your options around how you make your requests out. The other thing you should consider is an API gateway. API gateways are used to kind of keep a layer of separation between your microservice system over here and anyone who wants to make external requests. So although you might have lots of different teams building the microservices, you still want to work quite closely together, and you still should have this idea of people external to your little group of microservices that are making requests in. And it basically just provides a mechanism for showing coarse-grained APIs up to the user. So because of the nature of microservices, and I mentioned they were kind of smallish, it means you'll probably have quite fine-grained APIs. And you don't necessarily want to expose them to an external person. And the main reason for that is because it means you're showing them exactly how you're doing everything. And in the future, if you want to change something, you can't, because people are relying on your very fine-grained APIs. So instead, you should consider having an API gateway that provides more coarse-grained APIs up to the external users. And then that means you are completely free to do whatever you want behind the scenes, and the external users will just never know. They're also useful for API metering and JWT injection. So if you need to kind of validate some of the requests coming in and understand whether or not that person is authenticated and what they might have access to, then an API gateway is quite a nice way to do this because you know there's just one entry point for all the requests coming in. So now I'm going to move on to talk about microservice communication characteristics. So I said earlier I was going to talk about synchronous versus asynchronous. And this is a topic that, when I showed these slides to my colleagues before I left the UK, there was some question around, well, what does synchronous versus asynchronous mean? And we kind of realized that people do talk about this on several kind of levels. So hopefully I'm going to describe to you how I see it, and hopefully it will make sense. But I'm basically talking here about synchronous versus asynchronous protocols. So a synchronous protocol is something like REST, HTTP. Obviously, if you use REST, you have to use HTTP. But this requires a response. If you make a request, you expect something back, whether or not that's just a message that says, yep, I received your request, that's fine, or whether or not that's some sort of payload back again. Whereas asynchronous protocols here, I'm talking about something like messaging. It's more of a fire and forget scenario. So you just have some data that you throw into some channel somewhere and you don't worry about it. And if someone picks it up at the other end, then that's fine. And I think that actually both of these are useful for microservices. I've seen various kind of blogs and things online that discuss which ones you should use, but I think they can both be very useful in the right circumstances. But before I talk about the circumstances where they should be used, I'm also going to point out that I've got here, you should utilize asynchronous programming models. So although I think synchronous requests are useful, it's worth noting that when you make a synchronous request, you are blocking the thread where you wait for the response. But you can use asynchronous programming models to hand off that thread, and then you're not actually blocking a thread, but you obviously are still waiting for that response back again. So where do I think you should use these? To kind of show you an example and show you where I think these are useful, I'm going to talk about Game On, which I mentioned earlier. So Game On, as I said, is our text-based adventure game. It's written in microservices. You can kind of see on the left, it's right to you, right-hand side, that you kind of enter commands and you can play around in this text-based world. So it's made up of a bunch of different rooms, and you can go into a room, you can have a look around, pick up objects, and then you can move from room to room by doing go north or go south or whatever. And the reason we decided to create Game On is because we wanted to find a nice, fun, different way to teach people about microservices. And we thought this would be a good way to do it because you can come in as a developer and you can write one room for the game. That should be a fairly simple application, hopefully. You can have a go at standing it up in the cloud somewhere. You can hook into our architecture and start thinking about how you would communicate with other microservices. But it means that from the starting point, it should be quite a simple process. And then once you're kind of comfortable, you can take steps forward in whichever direction that you want. So for example, say you decide, well, I'm going to do some scaling, and I want to have 2 instances of my room available. Well, once you've stood up 2 instances, you might have someone in the game who's gone into one instance and someone else who's gone into a different instance. But how do you make sure that the 2 people in the 2 separate instances of your room see each other? How do you make sure that they actually feel like they're in one room, not 2? And then you have to start thinking about, well, do I use eventual consistency? Am I going to have some cache data or something? And we found that actually by creating a room and doing something that's a little bit different from what you would do day to day, it kind of gives you the chance to explore concepts that are new and exciting in microservices in a kind of new setting. And then once you've kind of learned and you understand what you need to do, then you can go back to your day job, whatever, and say, oh, well, I can see now how we can apply this to what I'm working on. So that was kind of the main reason why we created it. And it's live. I'll put some links up at the end, and you can go and play it if you want to, or write rooms or whatever. But we created it, and we now take it out to conferences and also to our clients, and we run workshops. And in the workshop, people create rooms, and then they can play around with their room, they can see each other's rooms and go and visit them. And because of that, we needed to create something called the interactive map. So this is the interactive map. It's basically a picture of all the rooms that are in Game On. I had to zoom in so that you can kind of see what's going on, but actually we have a ridiculous number of rooms at the moment. And this is a picture of rooms that are live, like currently being hosted on cloud platforms somewhere and hooked into the Game On system. And the basic reason we created it was just so that when you come along to a workshop, you can create your room, register it with Game On, and then you can go look on the interactive map and see it appear so you know it worked. And it just displays the name of the room and the location on the map. So the example I'm going to use to show where we can use asynchronous versus synchronous protocols is a user who has created their room, they've registered it with Game On, and then they want to update the name of their room. So we have here the UI, and that's how I would go in and update my room. And once I've updated it, I want some sort of response that says, yep, that's done. And then at some point in the future, I need to be able to look on the interactive map and see my new name appear. And we've structured this kind of flow to look something like this. So the authenticated user comes in at the top, and they're making a REST request to the map service. The map service is our service that understands everything about the map. So it's in charge of the data store that has the list of where all the rooms are in comparison to each other. And if you want to make some sort of update, then you go to the map service. And the reason this should be a synchronous request rather than asynchronous is because me as the user, if I come in and say I want to change my name, I expect that response. I want someone to come back and say, yes, that was successful, or no, that wasn't successful, you'll have to try again. So that should be synchronous. Then there was the question of how do we get the interactive map to see that update? And we could have the interactive map make synchronous requests to the map service to say, oh, have you got new data? Oh, no, you haven't. Oh, have you got any now? And then keep going back and forth. But that's extra traffic that we don't actually need, because the interactive map isn't one of our core systems. It doesn't need to be up to date. It's nice if it's, pretty up to date, but it doesn't need to be to the second, a perfect view of the world. So we can use messaging instead. We can have the map service send out a message to some sort of message broker, which would then be subscribed to by the interactive map, and then it receives the request. And by choosing this model, we've made good use of both synchronous and asynchronous requests. And it means that the user gets what they expect, and the interactive map gets the data that it needs. In Game On specifically, in case you're interested, we're using Apache Kafka. Here's an example of the code. All of the code for Game On is actually open source, so if you want to go look at it kind of in more detail and see how we're building up things like our events or anything else to do with Game On, then you can, and I'll put the links up at the end. And the reason we chose Kafka was because it's a nice way to send messages, but also there's a service called Message Hub in the IBM Cloud. So we have all of our services deployed in containers onto the IBM Cloud, and Message Hub is based off of Kafka. So when we're creating microservices, we strive a lot to get high parity between our local development environments on our laptops and what's up in production. So by using Kafka, we can have our application using kind of the Kafka client and things, and then it gets easily put up into production. We don't have any problems. So that's kind of an example of where you can use both synchronous and asynchronous. So next I'm going to talk about microservice design and how it should be influenced by communication. So when you're coming up with the idea of your microservices, it might be kind of easy to think, well, we'll just decide which services we need and everything, and then we'll kind of worry about communication once we've stood them all up somewhere. But I think that actually you should really consider what communication your microservice is going to have as part of your design kind of approach. And one of the reasons for this is because of latency. Because actually, if you have two microservices, for example, that when a request comes into one, it always has to make a synchronous request to the other one and then get the response and everything, you might find that over time, your users experience latency. And actually, if you have several microservices in a row, so if you have a request that comes in, it calls another one, which calls another one, which calls another one, which then gets a response back and back up the chain, you're definitely going to see latency. And you might have not had to worry about it kind of in a monolithic world, but now that you're on a distributed system, latency is definitely a problem. So you should really consider, how are my microservices going to communicate, and how will that influence how I should split them up? And to kind of give you an example of that, I'm going to talk about Game On again. So this is our architecture for Game On when we first started out, and we structured it after a hotel-style model. So we have Proxy as kind of the front-end piece, and we have Player. So Player understands everything to do with the game player. And then we have a room, because we knew we wanted people to come along and join us and write rooms, so we needed one room to get started. And then we have the idea of a concierge. In a hotel, a concierge shows guests to their rooms. So the concierge was just there to show players to their rooms. When you come into Game On and you access the UI, you can send messages. Like I said, you can say, like, go north, go south, look around, or whatever. And you can also chat, so you can type hello and other people in the room can see it. And to facilitate this, we set up a long-running WebSocket. And so initially, that was going from Proxy, which kind of links to the front end, into the player service, and then is pushed across to Room. And we kind of set this up, and we're like, cool, sorted. But then as we went on, we kind of started thinking about, how are we going to do communication, and what other services do we need? And we realized that actually this was a problem because of scaling, because we wanted to be able to scale really efficiently. But a long-running WebSocket actually scales quite differently to the REST requests that would come in to update the name of your player, for example, or what their favorite color is. So we moved to this model instead. So we added something called the mediator. The mediator mediates between the front end and the room. And that's what's then hosting the WebSocket, the long-running connection. And then we have the player, which has the REST requests coming in. And this is just one example of how we've actually had to rethink our design because we didn't think about kind of how will the communication impact the way we do things. We didn't think, oh, well, actually, we're going to be using this form of communication here, which might need to scale in a different way. And if we'd have thought ahead, we could have put mediator in immediately. So hopefully I've kind of give you an idea of the different infrastructure options you have. And now I'm going to talk about producing and consuming APIs. So the first golden rule of APIs is APIs change. It's quite nice to kind of assume that you'll get everything right the first time, and you'll write your API and it'll all be good forever. But actually, in my opinion, that's being quite pessimistic, because you want people to use your API, and you want people to want more from your API. So you want to be able to extend it, make it even better, and get it to provide even more. So you should be optimistic and assume that your APIs will change. And there are some kind of different kind of changes you might want to make. There are ones that are sort of typically breaking changes, like altering methods or changing the data that's coming out. Or there's non-breaking methods. So you could add some data, or you can add some methods, and theoretically that shouldn't break anyone. But unless everyone is being a good consumer and producer of APIs, then actually that can cause problems too. So first I'm going to talk about being a good consumer. The first thing you should consider if you're consuming APIs is you should always accept the unknown. So for example, if you're taking JSON in, it might be that you want to process that JSON in some way and turn it into Java objects so that you can then do something with the Java objects. And you should always accept unknown values and things in your JSON object coming in. And actually, some of the processing sort of frameworks and things, they do build this in. So this example up here, this is from Game On again, and that's using Jackson to process the JSON into a Java object. And you can see you just can use an annotation. At JSON, ignore properties, ignore unknown equals true. And this actually goes just in front of the class declaration for your model. So room info is a model of some Java object that we're being passed in. So if you use the right systems like Jackson, then actually you get this kind of thing for free. But you should always make sure you accept the unknown in. The second one is only validate against the required. So if I go back to kind of Game On examples, if I make a request to map, to say I want to know the name of a room, but it returns me the name and the description, and then I have something in my code that validates, oh yes, we got the name and we got the description, but then I just do something with the name and not with the description, then if in the future someone changes the API and they stop giving me the description back, then I'm broken. Except I shouldn't be broken because I don't need the description, so why on earth am I validating against it? So only validate against the things that you actually require back. The other one that I've put up in here is fault tolerance. Fault tolerance is really important when you're doing microservice communication. And you should use it pretty much everywhere. So not just when you're calling other microservices, but also when you're calling things like Cloudant. Because Cloudant, for example, might be hosted somewhere on the cloud, but you don't know if that's going to go down or be available. Or if you're reading files from GitHub, what happens if GitHub goes down? So you should always use fault tolerance whenever you're making outbound requests. I'm not going to go into details here about all the different options for fault tolerance because there are plenty, but it's things like timeouts, circuit breakers, bulkheads. If you want to learn more, there was actually quite a good talk about fault tolerance in microservices last year at Jfokus, so you should go check that out on the website. I can't remember offhand who gave it, but fault tolerance is definitely something that you need to consider when you're writing your communication. So whenever you're writing a request out to an external service, just put some fault tolerance in there. Next one is being a good producer of microservices. So the golden rule is don't break your consumers. And if you need to break something, use versioning. So this comes back to what I mentioned earlier around if you want to alter methods or you want to alter the data that's coming back. Instead of altering it in your existing API, just create a new one. And in fact, when you first create your API, you should just start off with versioning. Don't assume that you sort it out at the beginning and you're never going to have to change it. Assume you're going to want to change it, and therefore you're going to need version 2 or version 3. So if you version from the beginning, then you should be all right. The next thing to consider is accepting unknown attributes in a request in. So if, for example, I'm the map service and someone makes a request and say, I want some information about this particular site, and then it passes in some random number that you have no idea about, rather than throwing back and saying, well, that's not the request that I was expecting, just return the data that you think they want and just throw out the extra thing that they passed in. Because why do you care that they pass something extra to you? Why should you care at all? So just accept unknown attributes. And then the final thing is to only return attributes that are relevant to the request coming in. So for example, if I'm the map service and then someone makes a call in and says, please can I have the name of this particular room or site, then I should only return the name, and not the name and the description and the location and whatever else, like all the objects in the room or something. And there's kind of two reasons for this. One is because if you return everything and then in the future say, oh, well, we don't think anyone's using the description when they call this API, so we're just going to stop returning it, then you're going to break your consumers because they may well be using it, even though you weren't expecting them to. The other reason comes back to not exposing the internals of your microservice. So this comes at both the level of kind of API gateway, where you don't want to expose the internals of how you've built your microservice to the whole world, but also in your little team that's building a microservice, you probably shouldn't expose how you're doing things to your team that sits over there, because then it stops you from changing things. In the world of kind of JPA, you're used to dumping all the data out and like sending everyone everything. But then that means in the future, you really stop yourself being able to iterate and innovate and change things and completely throw out the bit in the middle and start again. And actually, I talked a little bit about it last year, but you should maybe think about having some sort of data anti-corruption layer in your application. So the way you build up your application internally is quite important. You should have your business logic and then some sort of layer in between your business logic and the logic that's receiving the requests and making the requests out again. And that means that you always have that little barrier, so you can always change your business logic and completely redo it if you want to without causing any issues. Cool. So most of this consuming and producing business comes down to something called the robustness principle. You can find it on Wikipedia. It's quite a well-known thing, which is be conservative in what you send and be liberal in what to expect. And the last two slides were pretty much a long version of this. So whenever you send things out, send out the minimum possible, and whenever you accept things in, just accept everything and just use what you need. So the last thing I'm going to talk about around APIs is documenting APIs. Now, when you're set up with your different teams that are working on different microservices, it's important to get some sort of understanding of how you're going to interact. And this kind of links back to what I was talking about at the beginning of the talk about how my team interacts. We had to set up some understanding and some guidelines of, where are we going to talk, how are we going to talk, what channels of communication are we going to use. And it's very easy to kind of all sit around a table and draw on a whiteboard and say, yeah, this is what our API is going to look like, and it's going to be cool and awesome. And then everyone goes away, builds their parts, and you put them together, push them up into production, and everything's broken. So instead, just document them in code in, for example, contract tests. And again, if you want to learn more about this, I talked about it last year, but basically, it's useful to have the consumer of an API write some contract tests to say, this is what we think we are going to be consuming. And then they can throw that over to the people producing the API, and they can validate it against it as well. And because it's written down, everyone should be on the same page, hopefully. I would still recommend that you kind of put everything into staging and then run some end-to-end tests and integration tests before you go ahead and push it all up into production. But if you've got consumer-driven contract tests, then you should have less things breaking in your staging environment than you would have done before. And for Game On, we've chosen to use Swagger to kind of document our APIs and facilitate this passing back and forth of information. There's a couple of reasons for this. One is because it's quite popular and people kind of know what it is, know how to use it. We also have a feature in Webs for Liberty that will allow you to generate this documentation. So we actually just write the annotations, and then we use the Liberty feature to auto-generate the JSON file, which is what's being showed up here. And actually, the Liberty feature is providing the UI that you see, but it's built on top of the kind of open source version. And the other nice thing about this is Swagger provides you the cool little try it out button. So if you haven't ever seen that, after the talk you should go on to Game On, you can click on the Swagger link and you can actually try out our APIs. And that's really nice because it not only helps out the teams who are writing the internal microservices, but actually if we want to encourage people to consume our APIs externally, like in the way we did with the interactive map, then they can come in and try things out. And actually, for some of our kind of APIs and things, we actually wrote them in JSON first and kind of stood them up, and we had other people writing services, consuming them to make sure we were happy with them before they were then actually implemented in code. So that's another option. So hopefully that's given you a little flyby talk of microservice communication. There is a lot to consider, and generally I would recommend that you consider communication alongside designing your microservice and defining what the kind of main aims of your microservice are. But the main points I've covered today are you should choose your service discovery and invocation method, and I've given you some different examples. If you want to go and have a look at how we're doing stuff in Game On, feel free. You should use both asynchronous and synchronous protocols, and I think both are useful. Maybe use synchronous in moderation because it can cause latency issues, but they are both very valid. As I said, design should be definitely influenced by your communication, and then also consider the robustness principle at all times. So that's the end of my talk. If you want to go and play Game On, I know I've talked about it a lot, but you can, and all the code is up there on the GitHub page, and we've actually got a bunch of different samples, so you can go and start writing a sample room with like a framework to get you started. We've got ones in Java, JavaScript, Go as well, I think. If you want to learn more about Liberty, but also if you want to read more about microservices, you can go look on where'sdev.net. And then the final thing I want to plug today is my Red Book that I wrote with some of my colleagues. It's an IBM Red Book about microservice best practices for Java. It's got kind of some of the things I talked about today, but also about testing and DevOps and design and all sorts of things. So it's free to download if you want to go check that out as well. So thank you so much for having me. I'll kind of leave it there now so you guys can all go ahead and go to lunch if you want to, or if you'd like to ask any questions, then I would welcome them now, or I'll be around for the rest of the day. Thank you.